This is day 15 of Advent of Cyber 2023, and this challenge is called Jingle Bell SPAM Machine Learning Saves the Day. Over the past few weeks, Best Festival Company employees have been receiving an excessive number of spam emails. These emails are trying to lure users into the trap of clicking on links and providing credentials. Spam emails are somehow ending up in the mailing box. It looks like the spam detector in place since before the merger has been disabled, damaged deliberately. Suspicion is on McGreedy, who is not happy with the merger. Problem statement. McGreedy has been tasked with building a spam email detector using machine learning. She has been provided with a sample dataset collected from different sources to train the machine learning model. So the learning objectives in this task, we will be exploring different steps in a generic machine learning pipeline, machine learning classification and training models, how to split the dataset into training and testing data, how to prepare the machine learning model, and how to evaluate the model's effectiveness. So for this challenge, you'll be needing to start the virtual machine and you'll be using it in the split mode. Overview of Jupyter Notebook. Jupyter Notebook provides an environment where you can write and execute code in real time, making it ideal for data analysis, machine learning, and scientific research. In this room, we will perform the practical on the Jupyter Notebook. It's important to recall that we will need to run the code from the cells using the Run button or by pressing the shortcut Shift-Enter. Each step is explained on the Jupyter Notebook for better understanding. Let's dive into the details. Exploring machine learning pipeline. A machine learning pipeline refers to the series of steps involved in building and deploying an ML model. These steps ensure that data flows efficiently from its raw form to prediction and insights. A typical pipeline would include collecting data from different sources in different forms, pre-processing it and performing feature extraction from the data, and splitting the data into testing and training data, then applying machine learning models and predictions. Step 0. Importing the required libraries. Before starting with the data collection, we will import the required libraries. Jupyter Notebook comes with all the libraries needed for machine learning. Here we are importing two key libraries, NumPy and Pandas. These libraries are already explained in detail in the previous task. So if we go over to the virtual machine and the Jupyter Notebook, which should be open, you can select the place we're importing and then do Run up here. So I've now imported those libraries. Step 1. Data collection. Data collection is a process of gathering raw data from various sources to be used for machine learning. This data can originate from numerous sources, such as databases, text files, APIs, online repositories, sensors, surveys, web scraping, and many others. Here we are using the Pandas library to load the data collected from various sources in the CSV format. The dataset contains spam and ham, not spam emails. I've never heard of ham before, but sure. So we run this, which is loading the CSV test/check dataset. Let's review the dataset we just imported. The category column contains the email classification, and the message column contains the email body shown as below. So if we run that, we should see output. So classification, spam, spam, ham, and the message, these are spam, this is normal, spam, and that's normal. Data frames provide a structured and tabular representation of data that's intuitive and easy to read. Using the command below, let's use the Pandas library to convert the data into a frame. It will make the data easy to analyze and manipulate. So we now run this one, and it has turned it into a data frame containing a classification and message. Step 2. Data preprocessing. Data preprocessing refers to the techniques used to convert raw data into a clean, organized, understandable, and structured format suitable for machine learning. Given that raw data is often messy, inconsistent, and incomplete, preprocessing is an essential step to ensure that the data feeding into the ML models is relevant and of high quality. There are several data pre-processing machine learning models. Each has their own ways to process data. Utilizing count vectorizer, machine learning models understand numbers, not text. This means the text needs to be transformed into a numerical format. Count vectorizer, a class provided by the scikit-learn library in Python, achieves this by converting the text into a token, word count matrix. It is used to prepare the data for the machine learning models to use and predict decisions on. Here we are using counter vectorizer, which is used to extract features from the text. So we first run the import, which is getting the count vectorizer. We'll now use the count vectorizer function to transform the message column into numeric, as shown below. And now if we print X, we now have a numeric number for the messages. Well, it represents the message. So step 3. Train, test, split dataset. It's important to test the model's performance on unseen data. By splitting the data, we can train our model on one subset and test its performance on another. Here's the variable X contains the dataset. We will use the functions from sklearn library to split the dataset into train data and testing data, as shown below. So we're importing the function called train test split. Now we're getting the classification from the data frame and storing it in Y. And using X and Y, we're going to be creating training and testing data, and it's going to be a 80-20 split. So X, the first argument, is the feature matrix X, which you obtained through the count vectorizer. The matrix contains the token counts for each message in the dataset. Y, the second argument, is the labels for each instance in the dataset, which indicates whether a message is spam or ham. To size 2, that is the 20% test, 80% train, and it returns 4 values. Xtrain, which is a subset of the features to be used for training. Xtest, the subset of features to be used for testing. Then Ytrain is the labels for the Xtrain, and Ytest is the labels for Xtest. Model training using naive Bayes. Naive Bayes is a statistical method that uses the probability of certain words appearing in spam and non-spam emails to determine whether a new email is spam or not. Naive Bayes classification works. Let's say we have a bunch of emails, some labeled as spam and others as ham. The Naive Bayes algorithm learns from these emails. It looks at the words in each email and calculates how frequently each word appears in spam or ham emails. For instance, words like free, win, off, and lottery might appear more in spam emails. The Naive Bayes algorithm calculates the probability of the email being spam based on the words it contains. When the model is trained with Naive Bayes and gets the new email that says, for example, win a free toy now, then it thinks win often appears in spam, so this increases the chance of the email being spam. Free is also common in spam, further increasing spam probability. Toy might be neutral, often appearing in both spam and ham, so after considering all the words, it calculates the overall probability of the email being spam and ham. If the calculated probability of spam is higher than that of ham, the algorithm classifies the email as spam, otherwise it's ham. So let's now use the Naive Bayes to train the model as shown below. So we're importing the class for the Naive Bayes, creating an instance of the class, and then we're fitting it for the training data. Xtrain, this is the training data you want the model to learn from. It's the token counts for each message and the training dataset obtained from the count vectorizer. And Ytrain contains the labels for whether it's spam or ham. Model evaluation. After training, it's essential to evaluate the model's performance on the test set to gauge its predictive power. This will give you metrics such as accuracy, precision, and recall. So we're going to be importing a classification report, and we're going to be trying to predict using our X test data. And we're going to be printing up the results of that report. So the classification report function takes in the true labels Ytest and the predict labels Yprediction, and returns a test report showing the main classification metrics. The report gives you insights into how well your model is performing for each class and overall in terms of these metrics. Precision, it is the ratio of correctly predicted positive observations to the total predicted positives. The question it answers is, of all the samples predicted as positive, how many were actually positive? Recall sensitivity, it is the ratio of correctly predicted positive observations to all the actual positives. The question it answers, of all the actual positive samples, how many did we predict correctly? F1 score is the harmonic mean of precision and recall and gives a better measure of the incorrectly classified cases than the accuracy metric, especially when there's an imbalance between classes. Support, it is the number of actual occurrences of the class in the specified dataset. Accuracy is the ratio of correctly predicted observations to the total observations. Macro, this averages the unweighted mean per label, and then weighted, the average for the support weighted mean per label. So now to test the model. So we've got a message here which appears to be spam. Then we're going to run a prediction on it and see what the prediction model gives. And the prediction model says it's spam. McSkitty has provided us with the latest emails and asked us to test our model on these emails. Let's run a model on some test emails to see if we can detect spam emails. So update the following code to include the test emails file and run the trained model against these. So this, we are going to be importing test underscore emails.csv. So let's import that, run the head of it just so we can see what we're working with. So we've got classification spam ham and the emails. So we're going to be transforming the message into the xnew. And we're going to be trying to predict it with xnew. And let's see what the results are of these test emails. So it's given a whole list of things and what its prediction is. So conclusion, this is it from the task. From the practical point of view, we have to consider the following points to ensure the effectiveness and reliability of the model. Continuously monitor the model's performance on a test dataset or in a real-world environment. Collect feedback from end users regarding false positives. Use this feedback to understand the model's weaknesses and areas for improvement, and deploy the model into production. So we'll now go back to TryHackMe, and we will go to the questions section. So what is the key first step in machine learning pipeline? So the first step is data collection, I think. Yep. Which data pre-processing features used to create new features or modify existing ones to improve model performance? That is feature engineering. During the data split step, 20% of the data set was split for testing. What is the percentage weightage average of precision of spam detection? So I think let's go back here and look at the previous results. Is that 0.98? Yep. How many of the test emails are marked as spam? Let's see. These are this one, and that looks like 3. And one of the emails that is detected as spam contains a secret code. What is the code? Guess let's check out the CSV. Let's expand this so we can see everything. And the secret code, I hate best festival. So let's go back here and type that. I hate best festival. Okay, so that is day 15 of Advent of Cyber 2023 completed. If you like this video, make sure to like and subscribe so you can watch me complete the rest of these challenges.